Alright, this is the first video in the vector calculus series. Going to start with normalizing vectors, which is one word that can be used for saying making a vector of length 1. Some of these vectors are often called unit vectors as well. Um, Whenever you see the word unit or something like that, it's going to mean that the vector is length 1, and I'd like to show why that's important. And so um, one of the very important uh, one is a very important number because it is a multiplicative identity. And so when you multiply something by 1, nothing is scaled. Um, a great example of this would be the Cartesian coordinates for vectors. So we've got our x cross y is z. Always make sure that your Cartesian coordinates are x cross y equals z. And what's going on here is that we have three directions, and they're all orthogonal to each other. That's what comprises a three-dimensional Cartesian coordinate. And so the key here is that we need pointers. And so we have little unit vectors that for some reason we call I hat, j hat, and k hat. And there's different ways to write these symbols. This is just the way I write them. But the most important thing to remember is that these are all of length 1. And why that's important, we'll kind of get to when we start talking about the dot product and projections. That'll be next video, I think. But for now, basically unit vectors indicate absolute direction without scaling lengths. So if we'd imagine that our vectors that indicate a direction were of length 2, then they would scale any other vector. Whereas because they're length 1, they're a perfect way of saying this vector is in this direction because 1 multiplied by anything is still that thing. Any vector can be created by combining one or multiple scaled unit vectors. So in other words, let's say I had a vector and that vector was 1i, 2j, and 0k. Well, 1i, here's my unit vector 1, but now I need 2 of the j vectors, so I'll go 1, 2 of the j vectors. So there's another j vector. And now I have my vector 1i plus 2j. So this could also be written as 1i plus 2j and then 0k. This notation right here is kind of the vector calculus notation that I've learned. And it's useful because writing I, j, and k all the time can get to be a pain in the ass. So to make any vector u of unit length to become normalized, which means to make it of length 1, also making it a unit vector, goes through this process. So for example, let's say that I have some vector u, and I want to know the unit vector of the direction u. So I'll draw a vector here. We'll call it vector u. And let's give it some components. So let's go ahead and say that it is, we'll say it's 2 in the x, 3 in the y, and let's say it's 6 in the k. So, or 6 in the z, whatever you want to call it. So what we have here is a vector u that is equal to, we're going 2 in the I direction, 3 in the k direction, and we're doing 6 in the k direction. 3 in the j direction, 6 in the k direction. And so this does have an intrinsic direction built into it. Any vector on this line will have the intrinsic direction of this vector. However, if we multiply something by this vector, this vector is going to scale that because it's not of length 1. And so how do we make it length 1? Well, what we do is we find out the Pythagorean's identity for the magnitude of u. And so what that is that would be your x component squared plus your y component squared plus your z component squared. And that's going to give you the magnitude of u. Some people will just write 1 bar on either side like this, kind of like the absolute value sign. But the correct way to do it is to do 2 bars on either side to indicate that you're not talking about an absolute value, but rather you're talking about the magnitude of this vector. And so what we're now looking for is we're looking for a unit vector for the u direction. And so we want some vector that points along u that only has length 1. Alright, so how we do that is we're going to take the actual vector u and we're going to divide every component by the scalar of the magnitude of u. And so this is going to give us a unit vector that points in the direction of u. And to indicate unit vectors, I do the house. So a little arrow on top and a flat on the bottom. That's the same way I do my I, J's, and K's. Some people will just put a hat on it, this little thing right there. But what this indicates is this is no longer just any vector. This is now a vector with magnitude 1. And so now you can use this as a direction without a scaling factor. So in other words, you can point things in the u direction without scaling them in ways that you don't really want. So that's the first lesson on unit vectors. And I'll see you next lesson.